Hello lovely people, and welcome back to the Nova channel. This is part 3 in Nova's build series, and we're going to talk about software today. There's a lot involved in this. We're going to talk about calibrating Nova's motors, debug controls, on and off switches for hardware, hardware controls, state machine timers, serial commands, so we may end up breaking this into 2 videos, a part A and a part B. So start with calibration of Nova's motors. I'll demonstrate a little bit on the power, the minimum requirements to get her motors moving and calibrated, and then we'll dive into the software from there. So let's get started. So for this project, we use 12 servo motors, as most of you know by now, and with that comes a lot of configuration variables and positions of the motors, and you want to make sure those are all in sync, all centered, all aligned with each other, etc. So during development, I came up with a spreadsheet to help me in that process, and it's probably still pretty useful to you guys today. So it's always been included in the root of the Nova project on GitHub. This file right here, motor Vars XLS. And I won't bother going over this in great detail because there is a previous video which I'll link to above and below in the description that goes over this file, the configuration files, and even calibration. So I'll link to that in the description. But essentially, you're going to start off with ignoring these numbers because these are my numbers, don't forget. You may want to just copy the whole thing and paste it down here. There are formulas in here, just summing going on, so be careful of that. Essentially, these numbers here you'll edit, and these numbers here will auto-generate. So where you'll start, basically, is you can see that my home positions are between 300 and 400. So if you set them all to about 350, that's a great starting point. You can ignore the min and max values for now. You're going to go through home values first, which I'll show in the next segment. So I won't describe that now either. And then the data from here is used in our motor configuration file right here, set up in arrays so that we can use it throughout the software. Now this NovaServos.h configuration file that we have in our Teensy code is identical to the one that we're going to use in our calibration code. So you're going to copy the file between the two sets of Arduino code. So that way when you're working in our configuration, you're going to be changing these numbers and tweaking them all through the process. Once you're done and happy with it, they should be in sync with your spreadsheet, and then you can just copy this file into your Teensy code and you're good to go. Okay, so let's take a quick look at Nova before we come back to software and Nova for the calibration process. So let's talk about powering up our motors. So when you're finished with the mechanical assembly and haven't done any of the wiring yet, you most likely will be anxious to fire up your motors. You can actually do so with the bare minimum hardware required would be the PWM controller connected to the Teensy. You don't even have to have the powertrain set up. You can just power up the PWM controller from your power supply. And then the Teensy we're going to connect via USB to the computer anyhow for calibrating, which will also power that. So that's all you really need. So for this demonstration though, I'm going to use my servo tester that has homing buttons and potentiometers to move the servos and connect up to 6 servos. So in the previous video, we've already homed our servos in hardware terms in part 1 of the build series, which I'll link above and below in the description. Before you apply any power to your motors, a couple of tips. One is Nova should be on her stand. If you're not going to use the stand, suspend her somehow so that her feet clear the ground. We're going to calibrate one motor at a time. Yes, the calibration software can activate all 12 motors, but you don't want to do that until you're sure they're all calibrated pretty well. In the calibration software, you can set the speed of the motors. I suggest starting off with a slow speed. And then when we're setting her min and max positions, for example, you want to increment very slowly to make sure that you don't overextend or jam up your servos. So for example, if I go that far, the heat sinks that I added end up hitting. So you've got to be able to increment it and walk up onto your min and max positions. And then as a final precaution, when you first start calibrating, or if you're unsure or a little paranoid of what's going to happen when you apply power, with each calibration step, I suggest keeping your finger on your power switch at all times so you could just kill the power if anything bad happens. In this case, I turned on the power. Okay, so I've already calibrated, so I'm not worried about it. But then the last thing is you should make sure, let me power off for a second. You should make sure that her legs are clear of all objects at their fullest extensions, just in case. I've even got this front leg pulled away to demonstrate that just in case. For your initial calibration, make sure you have clearance all around. And then one final note to be very careful on the other side of Nova, when you have your Teensy connected via USB, let's see if I can simulate this for you. You'll have your cable in like that. That's when you have to be very, very careful, guys. You may do your best to tape it out of the way, something like that, because yes, I've torn the USB right off of my Mega about a year ago in this process. So things to be aware of in testing and calibration. Okay, so as I said in previous video, at assembly time, we made the leg perfectly straight in its homing position. So if I go ahead and home my servos, that's what I have. So I assembled it correctly. If you see something skewed like this, then yes, you didn't assemble this joint right. And if it's off a couple of degrees, not a big deal. But I would say any more than 15 degrees or so, you're better off disassembling the joint enough to at least move that servo horn and gear a notch or two to get it as straight as possible. Because that is really our ultimate starting points, okay? And then what our goal is to get something like that for her initial stand position. You can see the most key point is that her foot is aligned underneath her shoulder. Now I just did this by hand, but mine is already calibrated properly, which we'll see in a minute. Nova's actual home positions is what this is. The hardware home positions, like I mentioned, is straight as we assembled, but our home positions are software based, which will be slightly different than the servo's hardware positions, as you can see. And in software, we want to establish this initial standing leg position, which again is Nova's home position. Okay, now that we have Nova set up and all the preliminary stuff is out of the way, we can start calibrating. This part of the video, I'm going to go into the calibration software, and this is version 2 of the software, and previous videos are using version 1. I'll still link to them here in the card and in the description, but I'm going to go into great detail in this. This will probably why this video is going to be split into 2. So let's dive in and get started with that. I'll do a split screen here so you can see software and Nova at the same time. Okay, so you can see we have Nova now connected up to the PC. I'm going to go ahead and show you how to use the calibration software. I just wanted to point out that I have this right angle connector for my Teensy to connect it so that my wire stays nice and clean out of the way. We're going to be working and demonstrating with this right rear leg. So I make sure the wire is out of the way of that one. And we'll go ahead and get started. Okay, so here we have the calibration software open in Arduino IDE. And then we also have the serial monitor open because we're all connected up to Nova. And I have mine set up to be testing the right rear leg, as I said. And then for now, just the coax is energized. Now, one word of caution here. When you first power up, first plug in your USB to Nova. In fact, let me turn on her power right now. Any motor you have set to 1 in here is going to get energized. So as you saw, that coax twitched a little bit and went into its home position, so now it's locked up. None of the other servos are energized right now. Okay? That's because of the PWM controller. We just told it to only energize this one servo. Now, word of caution. If you now are done with this servo, homing it, and then you go ahead and energize a different one, if I go ahead and upload this code now, be very aware that any previously energized ones are still going to be energized. The only way to de-energize them is to completely shut down, which means kill your power and disconnect USB so that the Teensy completely powers off. Because right now, my coax is still powered, as is now my femur, since that's the one that I just turned on. Tibia still not. So the only way I could free those up now is to completely power down, completely unplug my USB, and then all motors will be de-energized. So just a word of note. Okay, so now that we're on the femur, we can start there. So if I go over to a couple of things also before we get started. I went over the spreadsheet. I'm not going to go over it in grave detail because there's a whole other video on that, which I will link to. We're pretty much going to be dealing with this first set of positions, which correspond to our config files. So if we come back over here to our calibration software, there's the NovaServos.h file. If we scroll down here, first is we did have some issues. Somebody got a little confused with the pin orders of this setup array here. I've mentioned this in previous videos, but I'm going to quickly mention it again. I originally used this code for my hexapod, which used 2 PWM controllers. That's what this first digit is for, and I think that may confuse some people. Because if you had 2, or more for that matter, you'd change the number there accordingly. And then the second number for each pair corresponds to the pin number on the PWM. Now, on the PWM controller, they are in banks of 4. It can take 16 connections in banks of 4. Since we're only using 12, me and my OCD, I chose to use the first 3 pins of each bank of 4. So I think that also puts a little confusion in. But again, the second number here is our pin numbers. So we go 0, 1, 2, then you see I skip 3, 4, 5, 6, then I skip 7, etc. Okay, this next array is just assigning names. You can ignore that. But these next 2 arrays are the 2 that correspond to this data in our spreadsheet. So our home column here are these home values here. You can see right front, right rear, left rear corresponds here. And then the order is the same, coax, femur, tibia. So it's coax, femur, tibia. Okay, and then this last array here is the limits, your min and max in that order, min and max. And then the same again, coax, femur, tibia. When you start to calibrate one of the joints, you will first set its home position until you're happy with it. And then you'll increment these 2 positions one at a time until you've made it to your min and max. Now, a lot of this is visual, unfortunately. You can use a carpenter square because ideally also our legs are at a 90-degree angle. And then, as I've said before, the toe should be straight under the shoulder. So with those 3 things, and then like this, or 2 things I should say, you pretty much can get your leg in the right position. The coax would be the bottom of the frame piece, should be nice and flat and level. So the coax is level in this direction. And then, like I said, this is a right angle, and the toe is directly beneath the shoulder. So you could come up with whatever kind of jig you want to use. I found a combination square works great. Steffi over on Discord came up with a little 3D printed gauge that you can also use. I don't happen to have it handy, but it's available on GitHub. So that's all there is to it, guys. It does require looking at it from this angle, and then also you have to look at things from this angle, especially when it comes to doing your second and third legs, because you do have to visually make sure they're all in line with each other as well as you home and min and max all your positions. All right, so let's quickly look at how the software works. So we're going to do the rear right femur. So currently its home position is 365. So if I just happen to change that to, let's say, 395 and go ahead and upload this, you'll see how it's going to increment a little bit from its home position. And that's really all there is to it. So now I can say, okay, well, I overextended that. Let's back it up a little. And the idea is, yes, to go back and forth and to tweak and change the positions until you get right to where you want to be. And then also keep in mind to keep your spreadsheet in sync and updated. Okay, so my suggestion is first home your coaxes, which are the easiest because like I said, they just have to be level on their bottom plane here. And then second to that is probably to do the tibia to the fibia to get that 90-degree angle that I talked about. So it doesn't really matter what position you work in. See, my femur is locked there now, but if we look at this femur, so if you have this all loose and you go ahead and walk this one and increment it until it's home at your 90-degree angle, then you're good there. Then you'll go ahead and walk this one until it's home so that your toe is straight up and down from the shoulder and your homes are calibrated for that leg. Okay? And then the min and max calibration. So for example, if we come down here now to the right rear min and max. Now, side note, you probably notice here that in the case of the left leg, they are opposite the right leg. So what that means is my right leg, the minimum is the smaller of the two numbers. The maximum is the largest. But when it comes to the left legs, it's the opposite. The minimum is the larger number, and the maximum is the smaller number. That's because we kept the motors in the same orientation, facing the same way on both sides. Therefore, it's counterclockwise, clockwise the other way. Okay, so that being said, let's go into our minimum setting here. And if I go ahead and I want to increase this because I'm already at my minimum, so I don't want to overextend my motors. So for this example, I'll just go ahead and add 30 to that. So we're going to move it to 67 instead. So I'll go ahead and upload that. And we won't see anything happen because now we're going, other than it homing itself again, sorry. That number that I just entered, we did not see yet because we have to go back here to our calibration software. And in here now, I do have my femur set as the active servo, but down here, a couple of steps is where you can set up the software. Okay, so now that we have test min active, we'll go ahead and upload this. And if we go ahead and open our serial monitor, we will see both now the home position and the minimum position. Okay, if we go ahead now and turn on test max as well, go ahead and upload that. And I'll open the serial monitor, and now we should see it go to its minimum position, then to its maximum position. This is where it's really important to get that USB wire out of the way, and then back to its home position. And then finally, when you think you're all done and you really want to observe how it's moving well, you could throw on the test sweep, as well as maybe increase the calibration loops. And then I'm going to set test min and max to 0 so that it doesn't pause on both of those tests as well. So now it should just test home, go through its sweep between min and max 3 times. And that's how you can verify the positions of your leg, and you're happy with that one movement, that one leg's calibration. You can come back to your spreadsheet, and this is where it starts to get a little easy. Sorry, let's pull this out here. So the rest of these numbers here are generated by your positions that you end up putting in your spreadsheet here. And they should all jive. As you can see, these 4 sets of 3 are all equal. These, in my case, are a little off because I've been playing around now with calibration, but these as well should all be equal in triplets, so to speak. So we've been calibrating this leg here. So once you've done your min and max for all 3 servos of one leg, and you have all of your home positions for all 12 legs, then the rest of these numbers you can calculate based on this distance, because this should be the same for each. And then travel min and max from the center position also should be the same, so that you go the same distance away from the center for your other 3 legs. So yes, you can calculate the rest of this, or you can incrementally go through each leg at a time and visually align them as best you can as well, and watch your numbers all jive up for you at the same time in this spreadsheet. All the while keeping it all in sync over here in your Nova configuration file. Okay, so once you're all done with all of your servo settings, and just for reference, the coax, we expect to get about 45 to 60 degrees of rotation out of it in this direction. Depending on what shoulder design you use, you can get more or less out of the up movement. And then the femur, we expect to get about 180 degrees out of it. So you should pretty much go level on both sides. And then the tibia, I guesstimate about 140 degrees. Reason being is, if you call that the one side of the 180 degrees, there's really no need to move her leg like that. That's just a goofy position that serves no purpose. So I clamp it at about its hardware home position, or that straight position. And that's about all the tibia has to move for her to be able to do all of her walking gaits. So yeah, that's about 140 degrees of movement on that motor. Okay, so once you're all happy with your one leg, and then you go ahead and calibrate your other 3 legs to match, then you're all done. And once you're done and happy with your configuration file in your calibration, the NovaServos.h file, once that's all done and you make sure that your numbers here, you kept them in sync so that you know that all of these numbers calculate out right and evenly so that these are all the same, then you can simply go and open your Teensy code. And I've mentioned this before. It uses the same NovaServos.h file. So now I can just go to my calibration file, Control A, Control C, come to my Teensy version of that file, Control A, Control V, and there you go. Now it's updated and ready to go. I'm not going to save mine because we've been messing around with my numbers a bit in calibration here. But there you go, guys. That's how she works. That's how the calibration software works. If you have any questions, I know I'm a little vague on how to use the software and all the settings and such, but we don't want these videos to be 2 hours long. So please reach out to me. Any questions, I will be happy to help, or join the Discord server. There's so many helpful people there. We'll find a solution to any problem that you may be having. Okay, guys, so that wraps up calibration. Your Nova should be well calibrated now, and now you'd be ready to install the actual Teensy software. So we're going to do a part 2 video on that because this video has been long enough, and the next one may be just as long, where we go over all the hardware controls in the software, all of the switches and settings, all the timers, serial commands, etc. So be sure to watch that video next, and that should complete the Nova build series. If you have any questions, any details needed, would you like further detailed videos on specific parts of the project, please let me know in the comments below, or reach out to me on Discord or through Nova's website, and I'll do my best to do that for you. So as always, please like, share, and subscribe, and be sure to check out the next episode. Take care, everyone.